In a groundbreaking announcement, scientists have unveiled the discovery of a celestial object unlike anything previously identified. NASA, celebrated for its trailblazing advancements, revealed that this object is not only remarkable for its size and position, but also for the mysterious light it emits, light that appears to be artificial in nature. Could we be on the brink of exposing hidden truths that could reshape our understanding of the cosmos? Might this discovery hint at the possibility of life beyond Earth? By exploring NASA's innovative achievements, we edge closer to unraveling the mystery behind this extraordinary phenomenon. One such milestone came in 2007 when NASA launched the Dawn mission, designed to investigate some of the solar system's most intriguing bodies. Powered by 3-ion propulsion engines, Dawn embarked on a historic voyage, beginning with a 14-month survey of Vesta, the second-largest object in the asteroid belt. The spacecraft returned high-resolution images and scientific data, shedding light on Vesta's complex surface and diverse geological history. Upon completing its observations of Vesta, Dawn advanced to what many consider the most thrilling leg of its mission, an in-depth study of the dwarf planet Ceres. Thanks to its advanced ion propulsion system, capable of gradual but continuous acceleration, Dawn successfully escaped Vesta's gravity and set course for Ceres, a feat impossible with traditional chemical propulsion. Ceres, first spotted in 1801 by Italian astronomer Giuseppe Piazzi, remains the largest object in the asteroid belt between Mars and Jupiter. For a time, it held the title of the smallest known dwarf planet until reclassification in 2006. Measuring roughly 950 kilometers in diameter, Ceres is the belt's most massive and expansive body, made all the more captivating by its distinctive features. Scientists were eager for Dawn's arrival, which promised the first close-up, high-resolution images of this enigmatic world. What those images revealed stunned observers: bright white spots scattered across Ceres' surface, especially within a vast crater called Decatur. These glowing regions immediately ignited curiosity and debate within the scientific community. Before Dawn's mission, our best views of Ceres were blurry, low-resolution images from the Hubble Space Telescope. Data about the dwarf planet was limited, and anticipation for detailed visuals ran high among researchers and astronomy enthusiasts alike. The mission aimed to deepen our understanding of solar system formation and examine the role water may have played in shaping planetary bodies. The luminous spots on Ceres, similar to features seen on other celestial bodies, were believed to be composed of highly reflective materials, possibly salts left behind after subsurface water sublimated. This finding hinted at cryovolcanism, a rare form of volcanic activity where water or brine, rather than molten rock, erupts from a planet's interior. But what exactly are these glowing anomalies? Could they indicate ongoing geological activity, or something far more extraordinary? Ceres distinguishes itself from most asteroid belt objects not only in size and mass, but also in its internal structure and likely reservoirs of water and ice. Unlike the rocky composition typical of asteroids, Ceres bears a closer resemblance to icy comets, making a valuable subject for learning about the early solar system. After a 2-year voyage, Dawn finally entered orbit around Ceres in early 2015, marking a historic moment. As the spacecraft approached, images sharpened, exposing a once-hidden terrain pockmarked with craters from ancient impacts. Yet it was a glowing spot scattered across the rugged surface that truly captured imaginations. As resolution improved, scientists began developing hypotheses. Were these patches simply ice reflecting sunlight, or could they represent something far more unexpected? The range of theories only fueled the mystery. From mineral deposits to signs of cryovolcanic activity, Ceres has revealed itself to be far more dynamic than once assumed. Surprisingly, further investigation showed that its brightest point wasn't a singular feature, but a cluster of glowing regions. The leading explanation suggests these are salt deposits left behind after water sublimated, transforming directly from solid or liquid into vapor. This discovery implies that Ceres either once had or still has internal processes capable of transporting water or brine to surface, which then evaporates, leaving behind reflective salt residues. These revelations challenge earlier notions of Ceres as a static, frozen world. Instead, it emerges as a complex and geologically active body, The possibility that Ceres contains underground water or salty reservoirs significantly boosts its potential for harboring conditions necessary for life. Ceres is often described as an icy world with rocky yet porous crust, unlike typical asteroids, which are mainly composed of dense rock and metal. Its surface is rich in water ice and hydrated minerals, such as clays and carbonates, giving it a lower density than most solid celestial bodies. This unusual composition indicates that large volumes of water may lie beneath its surface. The crust itself is rocky but filled with voids, ice, and volatile materials, making Ceres resemble a comet more than a conventional asteroid. Internally, scientists believe Ceres has a layered structure that includes a solid rocky mantle and a cold, icy core. Water ice could make up nearly half of its total volume. The mantle is thought to consist of rock mixed with salty liquid, surrounding a denser core, likely composed of silicate material. This high water content supports the idea that Ceres may have once hosted liquid water, especially if early internal heat was generated by radioactive decay. Such a structure sets Ceres apart from its rocky counterparts and raises fascinating questions about water's role in shaping its evolution. Adding to the intrigue, the detection of ammonia-bearing clays on Ceres suggests it may have originated in the frigid outer reaches of the solar system before migrating inward. Ammonia acts as an antifreeze, lowering the freezing point of water and allowing salty liquid to persist near the surface. These chemical clues expand our understanding not just of Ceres, but of how cold, distant objects evolved throughout the solar system. Cryovolcanism, an uncommon geological marvel. Cryovolcanism, volcanic activity involving the eruption of icy substances, is rare and intriguing. Unlike Earth's lava-driven volcanoes, cryovolcanoes eject water, ammonia, or methane, which remain liquid or gaseous even in extremely cold environments. On Ceres, this activity allows brine-rich fluids to reach the surface. Once exposed to the vacuum of space, they rapidly sublimate, leaving behind glimmering salt deposits. These are the source of the bright, reflective spots seen across the planet's surface. The most famous of these is located in a crater known as Spot 5. This region has attracted significant attention due to its intense brightness and observable changes over time, likely caused by ongoing or recent sublimation activity. These shifting features hint that cryovolcanism may still be active on Ceres. And Spot 5 is just one of many. Numerous bright areas to surface, each exhibiting distinct traits and spread across various regions. Their widespread distribution suggests cryovolcanic processes are not isolated events, but part of a broader, planet-wide activity. This challenges earlier perceptions of Ceres as geologically inert. As NASA's Dawn mission continued to send back high-resolution imagery, it revealed a world covered in craters, each telling a chapter of Ceres' complex history. New perspectives and lasting questions. These groundbreaking observations have reshaped our view of Ceres. Rather than a dormant, icy relic, it's now seen as an evolving, potentially active world. Its icy surface, ammonia-rich minerals, and glowing salt deposits all point to a planet shaped by internal activity and complex chemistry. The mysterious bright spots, especially those inside prominent craters, continue to puzzle and inspire scientists. They may signify more than geological forces. They could be markers of conditions once, or still, favorable for life. Understanding subsurface water and the broader implications of studying Ceres. Exploring Ceres isn't just about examining a single dwarf planet. It's a gateway to understanding a much larger class of icy worlds across our solar system. By analyzing Ceres' internal structure, surface features, and reflective materials, scientists gain valuable insights into the makeup and behavior of other frozen celestial bodies. The presence of frozen water, ammonia-bearing clays, and sparkling salt deposits reveals important clues about the chemical composition and environmental conditions on similar objects. The evidence of cryovolcanism on Ceres opens up thrilling new possibilities in planetary geology. This phenomenon, where icy materials erupt instead of molten rock, suggests that geological activity may be more widespread, potentially extending to icy moons, dwarf planets, and even far-off exoplanets. Such activity implies that worlds once dismissed as lifeless and inert might, in fact, harbor complex internal processes. Could this also mean that frozen planets previously seen as barren might actually possess some of the key ingredients for life? Reflections on NASA's Dawn mission and the ongoing quest for cosmic understanding. NASA's Dawn mission remains a brilliant example of what space exploration can achieve. The wealth of data collected has already reshaped our understanding of how planets form and evolve within our solar system. As we delve deeper into the mysteries of Ceres and other distant worlds, each discovery adds another piece to the grand puzzle of planetary science. The bright spots on Ceres, once just curious anomalies, now stand among the most captivating enigmas in planetary research. Yet, they are just the beginning. With rapid advancements in space technology and more exploratory missions on the way, many more groundbreaking discoveries await. Once a little-known object tucked within the asteroid belt, Ceres now represents a beacon of scientific promise. Its surface characteristics, internal composition, and mysterious glow may ultimately help unlock secrets of the solar system's history and the dynamic processes that have shaped its worlds. The idea that microbial life, or at least its building blocks, might exist on Ceres is both fascinating and inspiring. As our understanding grows, the line between science fiction and scientific reality continues to blur. Could hidden subsurface lakes on Ceres sustain tiny life forms? Might other icy planets shelter creatures unlike anything we've known? These are the compelling questions that will drive the next generation of space exploration, and perhaps one day lead us to uncover some of the universe's most profound truths.